Watch a rocket leave the pad. Millions of pounds of explosive thrust force thousands of tons of metal straight up into the sky. It looks like the ultimate battle against gravity. But the edge of space is only about 62 miles above us. If you could drive a car straight up at highway speeds, you would cross that boundary in an hour. Reaching that altitude puts a spacecraft on a suborbital trajectory. You go up, cross the line into the vacuum of space, and then gravity pulls you straight back down to the ground. To stay in space permanently, you need an orbital trajectory. This means entering a path that endlessly circles the Earth without ever hitting the atmosphere. Pushing a rocket 62 miles high simply requires enough fuel. Keeping it up there is the actual engineering bottleneck of human spaceflight. Space is a true vacuum. It is a harsh environment, completely devoid of matter and atmospheric pressure. Down here, movement requires friction. A car's tires push against asphalt. An airplane's wings push against air. Up there is absolutely nothing to push against. To move in a void, engineers rely on Newton's third law of motion. Every action has an equal and opposite reaction. A rocket moves forward by violently expelling onboard mass backward. The heavy toll of spaceflight is that a vehicle must carry an immense amount of its own weight for the strict purpose of throwing it away. This is why rockets don't actually fly straight up. Shortly after clearing the launch pad, they perform a gravity turn, pitching sideways to build horizontal speed. Altitude puts the spacecraft in a vacuum. Sideways, horizontal speed keeps it there. Newton imagined firing a cannon horizontally from a mountain. Gravity pulls it down. With more thrust, it travels further as the Earth curves away beneath it. Fired at 17,500 miles per hour, its trajectory perfectly matches the planet's curvature. This is orbital velocity. Objects in orbit are not defying gravity. They are falling. They are just moving sideways so incredibly fast that the Earth continuously curves away from them. Look at the International Space Station. When we see crews floating inside, it creates a persistent illusion that there is zero gravity in space. The station orbits roughly 250 miles above the surface. At that altitude, the Earth still exerts 90